Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 739, daily temperatures. So for this problem, you're given an array of integers, temperatures, that represents the daily temperatures, and you need to return an output array answer such that answer at I is the number of days you have to wait after the ith day to get a warmer temperature. And if that's not possible, then you return 0 for that day. So for example, we're given this input temperatures right here. And for so the first temperature is 73. And so you want to look through the array and see how many days it takes for you to get a higher temperature. So the next day, there's a higher temperature, which is 74. So it only took one day for there to be a higher temperature. The same thing is true for the next day, 74. So 74, the next higher temperature is the next day, 75. So that output for that day is 1. Now for the next day, 75, the next day after that, the temperature is 71, which is not greater than 75. So you still are looking. So then you look the next day after that, and that is 69. That's not greater than 75, so you have to keep looking. Then you look for the next day after that. That next day is 72, and that's not greater than 75, so you keep looking. And then finally you find a greater temperature than 75, which is 76, and that took 1, 2, 3, 4 days. So the answer is for that day is 4. So that's how you would get the result array. You just keep on finding the next day with the higher temperature. But for some days, you can't actually find a higher temperature. So for 76, there is no higher temperature because the next temperature after that is 73, which is lower, not higher. So the answer is going to default to 0. And again, for 73, there is no higher temperature because there's no other, that's the last element in the array. So there's no other temperatures to look at. So the answer is going to be 0 for that day. So that is what the problem is asking you to do. So how can we figure this out? How can we get the answer array programmatically? Well, the brute force way to do this would just be for each temperature, you loop over and look for a lower temperature. So for you look to the right for a lower temperature. So for 73, you would look throughout this entire array. So, and then for 74, you'd look throughout the entire rest of the array for the lower temperature until you find it. For 75, you would look through it. The next, you would look through it, and you continue on that way. So you can see that that solution would be an O of n squared solution for our time complexity. And that is because for every element in the array, you would have to loop over the rest of the elements in the array, or the rest of the elements in the array. So that would end up being a O of n squared time complexity. So is there any way we can do better than that? Well, there is a way that we could do better than that. What we could do is we could use a monotonically decreasing stack. So we could have a stack that is always decreasing. And if we have a stack that is always decreasing, we can figure out what the next high temperature is. So let me show you how we could do that. So this is our temperature array, and this is our answer array. And this represents our stack. And our stack is going to be always decreasing. So anytime you put a number on the stack, it's going to be a smaller number. So 73 is on the stack, and we can't put 74 on the stack because that would make this stack increasing. So we can't put 74 on the stack. So we have to pop off of the stack before we put 74, and then we have 70. Then we can put 74 on the stack and continue on that way. So let's go through this example and see how we can get the correct output. So we have our temperature array, our answer array, our stack, and we're going to loop through our array. So, and we're going to remember that we're always going to make everything on our stack decreasing. So we put our 73 on the stack. And because there's nothing on the stack at first, so we just put our 73 on the stack. Then we also keep track of what index 73 is. So we're going to have a tuple on the stack where 73 is our temperature and our index is the next thing in the tuple. And then we're going to go to 74. Now we have 74. Can we put 74 on the stack? No, because if we put 74 on the stack wouldn't be decreasing, it would be increasing. So what we need to do is pop off of the stack. So we pop 73 off of the stack. That means that we found a number that is greater than the number that we just popped. So we can get the number of times, the number of spaces it took to get a higher temperature by doing the index that we're currently on, which is 1. So I minus the index of the stack, the index of the top of the stack. So top I. So that would be 1 minus, and in that index you can see it's right here, so it would be 0. So 1 minus 0 is going to be our answer right here that we put here. Now we can put 74 on the stack because we popped 73 off first. So we're going to put 74 on the stack, and put its index as 1. Now we move on to 75. 75. Can we put 75 on the stack? No, 75 is greater than what's on the top of our stack, which is 74. So we're going to need to pop. And when we pop, we know that we found a number that is greater than the number that was on the top of our stack. So we can do I minus top I. So we can do 2 minus 1, and that gives us 1. So we found the higher temperature day. So now we can pop this off of our stack, and we can put our 75 on the stack. So 75 is on index 2. And so 71. Now we go to 71. Can we put 71 on the stack? Yes, because that would be decreasing. So it's still always decreasing. So we can put that on the stack. Now we have 69. Can we put 69 on the stack? Yes, because it would still be decreasing. So we put 69 on the stack. Now we come to 72. Can we put 72 on the stack? No, because now 69 is less than 72. So if we put 72 on the stack, it wouldn't be always decreasing. So we're going to need to pop. So we pop off 69. And 72 has an index of 5. 69 has an index of 4. So we do our I that we're on, which is 5, minus our top of our stack with I, which is 4. And we get the index, we get the number that it took, the number of days that it took for the num at this index to find a higher temperature. So we make that a 1 right here. Now we still haven't found the higher days for 71 and 75. So let's keep going. So we were trying to put 72 on the stack. So can we put 72 on the stack now? Well, 71 is on the top of the stack. So 71 is less than 72. So we can't put 72 on top of the stack because it would make it increasing. So we pop 71 off of the stack. So now we have 71 and 3. And 72 was still 5. So we do 5 minus 3 and we get 2. And that is our answer for the 71 day. So we put a 2 here. Now, can we put 72 on the stack? Well, 75 is greater than 72, so we can put 72 on the stack. Now we're up to 76. So can we put 76 on the stack? Well, we can't because 72 is less than 76. So we can't put 76 on the stack. So we're going to pop 72 off of the stack. So we pop this off, 72 and 5. And then we do 76 and 6. 6 minus 5 gives us 1. And, all right, now can we put 76 on the stack? No, because we have a 75 is on the top of the stack, and 76 would be increasing from 75. So we pop 75 off the stack. 75 and 2. So then we do our I, which is 6. So 6 minus our top I, which is 2. 6 minus 2, which is going to be 4. And that is the answer for the 75 day. Okay, now we can finally put 76 on the stack because there's nothing on the top of the stack. So we put 76, and then now we go to the next day, which is 73. We put 73 on the stack because it would be decreasing. And that is the end of our algorithm. So we can't pop anything else off of the stack because we haven't found any higher days, higher temperatures. So when there is no more answers, we just fill this up with 0 and 0. And we can see that this answer is the same as the correct output. And so that is how you do that algorithm. So let's see it coded up. So the first thing that we're going to need is we're going to need our answer array, which is going to be initialized as a array with the same length as our temperatures, with an empty with zeros to start off. And then we're going to have our stack, which is going to be an empty list that we can use our Python list for a stack because we're just going to be pushing and popping. So now we're going to loop over our temperatures array. So we're going to do for I in temp, in enumerate. So enumerate's going to give us the indices as well as the temperatures. And then we're going to be seeing if we need to pop off of our stack. So we're going to do while there is something in stack and stack at -1, which is our top of our stack, is less than our temperature. And remember that our stack is going to have a tuple. It's going to have our temperature and it's going to have our index. So we're going to do the top of the stack, and then we're going to get from the tuple, we're going to get the actual temperature. So that's going to be 0. So stack -1, 0 is less than temperature. While it's less than the temperature, then we know that we need to pop. So we're going to pop. We're going to do stack dot pop, and that's going to give us our tuple. So we're going to get our top temperature and our top index. And so now that we have our top temperature and our top index, we're going to take that top index and to our answer array at our top index, we're going to say how many spots away we found our higher temperature. And we found our higher temperature using our formula I minus our top I is going to give us our how far away our greater temperature was found. So now we popped off all of the lower temperatures. So now we can append our our high temperature. So we're going to append our temp and the tuple in the second thing in the tuple, we're going to give it I. And then we're just going to return answer. And we don't need to handle the case of the end at the end when there is no temperature at the end, because we initialized, there are no higher temperatures at the end because we initialized our answer to 0. So if we never pop and update this answer here, then it's just going to default to 0. And that's the code. So let's run it and see what happens. So we're getting the correct answer. Now let's submit. And it's taking a little bit, but it was finished. And we can see that it was successful. And so that is that problem. And thanks for watching, and I'll see you in the next video.